With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, let's take a question. So here the question is the total number of stereoisomers possible for the given molecule, okay, will be. So here we need to find out the stereoisomers. So if we talk about the stereoisomers, so stereoisomers are those which have the difference in the relative arrangement of atoms, relative arrangement of atoms, okay, or the groups in a space, or groups in a space. Okay, so we can say that these are those compounds which have the same molecular and the structure formula but the different spatial arrangement. Okay, different is what? The spatial arrangement. Spatial arrangement. Okay, the different is the spatial arrangement. Okay, so that is also referred to the configuration, or we can say that they have the different configuration. Now we need to find out the stereoisomers. Okay, so here we are not specified about what type of stereoisomer. So here we will use the formula 2 to the power n. Okay, here our n is the number of stereogenic centers or stereo centers. Okay, the number of stereo centers. Now the question arises, what is stereo center? We know we have one chiral center term. So in the chiral center we have the carbon in which that is our tetrahedral carbon, and it is attached to the four different atoms or the group. But when we talk about the stereo center, okay, when we talk about the stereo center, so here let's take the example for the stereo center. Okay, so first here we have CH3, here we have HOH, here we have NH2. Okay, and when we will interchange the positions between CH3 and H, okay, so here what we will have CH3, here we have OH, here we have NH2, and here we have H. So this is our stereo center. This is our stereo center now. And if in this case we also have the double bond, this is CC, ClH, here we have Cl, here we have H. So this is our stereo center. How this will be our stereo center? Because we will change the position between H and Cl. So here we will have Cl, C double bond C, here we have H, Cl, and here we have H. Okay, so now this is our stereo center because with respect to this carbon the position have been interchanged. Okay, so now here we have one term that all the chiral centers, if we have the chiral centers, all chiral centers are stereo centers, but all stereo centers will not be chiral center. Okay, all stereo centers are not chiral, are not chiral. Okay, so suppose because when we have the chiral center then we also see that we have the four different groups, but here we have the double bond, so it will not be chiral, but it is the stereo center, but it is the stereo center. Okay, and we can remember by this also that the chiral centers are sp3 hybridized, but stereo centers can be sp2 or sp3 both hybridized. Okay, that can be both. So now if we see this structure, okay, if we see this structure, so if we talk about the this ring, okay, in this ring we do not have any chiral center or any stereo center. Okay, here this is also not chiral because three hydrogens are attached, but when we have the chiral center four different groups are attached. But here this is our chiral center, this double bond position. Okay, because when we will have this it can be represented like this, C H double bond CH, and here this whole benzene group, here whole benzene. If we change these two positions then it will be our stereo center, and same goes with this carbon, right, same goes to this carbon. Now here if we see, okay, here if we see this is our chiral, or we can say the stereo center. How? One this chain, one this, one this, and one hydrogen. Okay, and similarly it is not chiral. Okay, here this is chiral, this is chiral, or we can say the stereo center. Okay, this one, because this cannot be, because here we will have the two same hydrogens. Okay, but this point is the stereo center. So in total in this we have the 4 stereo centers. Okay, we have the 4 stereo centers. Others are not, because here we have studied that all chiral are stereo, but here we do not have any other chiral center because they will have the same groups, like same hydrogens. Here we have same 2 hydrogen, 3, here 3, here also 3. Okay, so that's why. So in total we have the 4. So 2 to the power n, that is equal to 2 to the power 4 is equal to 16. It means that for this compound we have the total 16 stereoisomers. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.